Welcome back, curious minds. Ever wondered what makes that ice cream taste so sweet or that lemon so sour? That's right. Thanks to our tongues, we get to enjoy that sourness, sweetness, and even bitterness of food. In the world of senses, our humble tongue often goes unnoticed, quietly working its magic day by day. But what if I told you that this humble muscle is secretly a superhero in disguise? Yes, you heard that right. The tongue isn't just a taste tester, it's a unique muscle, a texture detective, and a speech savior, all rolled into one. Today, we are going through 9 interesting facts about the human tongues that you probably did not know about.
Facts number 1. The human tongue contains between 2,000 and 8,000 taste buds. These tiny sensory organs are responsible for detecting different tastes such as sweet, sour, salty, bitter, and the recently added flavor umami. Taste buds are small, onion-shaped structures located on the papillae, which are tiny bumps on the tongue's surface. Each taste bud contains multiple taste receptor cells, known as gustatory cells. Gustatory cells have specialized receptors on their surfaces that are sensitive to different types of molecules found in the foods we eat. These receptors are responsible for detecting 5 basic tastes: sweet, sour, salty, bitter, and umami. If you are wondering what umami is often described as a savory, meaty, or brothy taste that is distinct from the other basic tastes. The term umami comes from the Japanese word umai, which means delicious. Some common sources of umami include meat, seafood, aged cheese, soy sauce, and mushrooms. When you eat or drink something, the molecules from the food come into contact with the taste receptors on the gustatory cells. These receptors bind to specific molecules associated with each taste. For example, sweet receptors bind to sugar molecules. Once the receptors on the gustatory cells are activated by the binding of specific molecules, they send electrical signals to nearby nerve fibers. These nerve fibers are part of the facial, glossopharyngeal, and vagus cranial nerves, depending on the location of the taste bud. The nerve signals generated in the taste buds travel along the cranial nerves to the brainstem and eventually reach the gustatory cortex in the brain. The gustatory cortex processes these signals, allowing us to perceive the taste of the food. The brain combines the signals from different taste buds to create our perception of taste. For example, if sweet and sour receptors are both activated, you may perceive the taste as both sweet and sour. While taste buds primarily detect the basic tastes, other sensory receptors in the mouth and on the tongue's surface help us perceive factors like texture, temperature, and spiciness. Moreover, taste buds can adapt to the constant presence of certain tastes. This is why a food item might taste less intense after you've been eating it for a while. It's also why foods may taste different when you eat them immediately after something with a contrasting taste. However, the number and sensitivity of taste buds can vary from person to person. This variability can explain differences in taste preferences and perceptions of taste intensity. Moving on to the second fact. Our tongue has unique prints. Just like fingerprints, each person's tongue has a unique pattern of bumps and papillae, making it a potential biometric identifier. However, they are not as commonly recognized or used for identification as fingerprints, but they do exist and can be used in certain contexts. The surface of the human tongue is covered in small structures called papillae. There are 3 main types of papillae on the tongue: filiform, fungiform, and circumvallate. These papillae vary in size, shape, and distribution across the tongue's surface. The arrangement of these papillae on an individual's tongue can form distinct and unique patterns, similar to the ridges and whorls on a fingerprint. These patterns can include swirls, grooves, and other variations. The specific arrangement and size of papillae on the tongue can vary significantly from person to person. This individual variation is what makes the tongue's patterns unique. Tongue prints are relatively stable throughout a person's life, but can change somewhat due to factors such as age, injuries, or certain medical conditions. However, the pattern remains relatively consistent. While tongue prints are not as commonly used for identification as fingerprints or even facial recognition, they have been explored as a potential biometric identifier. Some research has suggested that tongue prints could be used for security purposes, such as in access control systems. Fact number 3. The tongue is a strong muscle. It's not only essential for taste, but also plays a crucial role in speech and swallowing. It's one of the most flexible and agile muscles in the human body. It is considered one of the strongest muscles in our bodies in proportion to its size and weight. While it might not be as large or visibly powerful as muscles like the quadriceps or biceps, the tongue's strength and agility are impressive. The tongue is primarily composed of skeletal muscle fibers. These are the same type of muscle fibers found in other voluntary muscles in the body, which means you can consciously control its movements. It has an incredible agility and flexibility. It can move in various directions and perform intricate tasks like forming speech sounds and manipulating food during chewing and swallowing. The tongue consists of multiple muscle groups that work together to carry out its various functions. These muscle groups include intrinsic muscles within the tongue and extrinsic muscles that are connecting the tongue to other structures like the jaw and hyoid bone. It moves to create different shapes and positions inside the mouth, enabling us to articulate different sounds and words. The precise control over these movements requires significant muscular strength. The tongue also plays a crucial role in the complex process of swallowing. It helps push food to the back of the mouth, initiate the swallowing reflex, and prevent food or liquids from entering the airway. During chewing, the tongue works in coordination with other muscles in the mouth to break down food into smaller, more manageable pieces. This requires a considerable amount of force. The tongue is in almost constant use throughout the day for various tasks like speaking, eating, and swallowing. This frequent use helps maintain its strength and coordination. The tongue plays a role in saliva production. Saliva helps break down food during digestion. An average person produces around 0.5 to 1.5 liters of saliva per day. Saliva contains enzymes, such as amylase, which begin the process of breaking down carbohydrates in food and helps in digestion. Saliva helps lubricate food, making it easier to chew and swallow. It also moistens the mucous membranes of the mouth, tongue, and throat, which aids in speaking and swallowing comfortably. It contains chemicals that dissolve and transport molecules responsible for taste to the taste buds on the tongue and palate. This allows us to perceive and enjoy different flavors. Saliva also plays a crucial role in maintaining oral health. It helps rinse away food particles, bacteria, and debris from the mouth. Saliva contains growth factors and proteins that aid in the healing of minor wounds or injuries in the mouth, such as cuts or ulcers. Adequate saliva production is essential for clear speech. Dry mouth, often caused by reduced saliva flow, can lead to difficulties in articulating sounds and words. Special thanks to the undercovered hero, our tongues. Another fact about tongues is that taste can change. Your sense of taste can change over time. Factors like age, smoking, certain medications, and medical conditions can alter your perception of taste. Let's take smokers as an example. Smoking can have a significant impact on your sense of taste. The chemicals in tobacco smoke can damage taste buds and impair their function, leading to a reduction in your ability to taste various flavors. This occurs because the taste buds become less sensitive to different tastes, making it harder to detect subtle flavors. Smokers often report a blunting or reduced perception of sweet and salty tastes, while some find that bitter tastes become more pronounced. Smokers may develop a preference for highly seasoned or spicy foods, as these flavors can still be detected despite the reduced sensitivity to taste. This preference shift can contribute to unhealthy dietary choices. Moreover, by reducing saliva production, smoking can lead to dry mouth. Saliva plays a crucial role in taste perception, by helping to dissolve and distribute the molecules responsible for taste. Dry mouth can lead to a decreased ability to taste and enjoy food. The good news is that many of these taste-related effects of smoking are reversible. When you quit smoking, your body begins to repair the damage, and your sense of taste can gradually improve. If you're a smoker and are concerned about the impact of smoking on your taste sensation, consider seeking support to quit smoking. Doing so can not only improve your taste, but also significantly enhance your overall health and quality of life. Taste map is a myth. The idea that different regions of the tongue are responsible for detecting specific tastes is a misconception. Taste receptors for all basic tastes are distributed across the entire tongue. The taste map, or tongue map, is a myth that has been widely debunked by scientific research. The idea behind this myth is that different regions of the tongue are responsible for detecting specific tastes, such as sweetness on the tip of the tongue, sourness on the sides, bitterness at the back, and so on. This concept has been perpetuated in textbooks and popular culture for many years. However, it is not an accurate representation of how taste perception works. The tongue map myth can be traced back to a misinterpretation of research conducted in the early 20th century. Scientists did identify different types of taste buds on the tongue's surface, but they never claimed that each type was responsible for a specific taste. Instead, they were merely identifying the presence of different types of taste receptors. Research has since shown that taste receptors for all basic tastes are distributed across the entire surface of the tongue. While certain areas may have a slightly higher concentration of specific types of taste buds, there is no exclusive zone for each taste. Taste and smell are closely connected. Most of what we perceive as taste actually comes from our sense of smell. As you may notice, when you have a stuffy nose, your sense of taste is often dulled. Geographic tongue. Some people have a condition called geographic tongue, where their tongue appears to have irregular, map-like patches. It's typically harmless and can change in appearance over time. Fact number 9. Taste can be acquired. Our taste preferences can be influenced by exposure and culture. What you grew up eating and your experiences with different foods can shape your taste preferences. If you grow up eating certain foods frequently, you are more likely to develop a liking for them. Different cultures have their own unique cuisines, flavor profiles, and culinary traditions. People tend to develop a preference for the foods and flavors associated with their culture. The people you spend time with and socialize with can influence your food choices and preferences. You may be more inclined to try new foods or adopt the tastes of your friends and family. Being exposed to a wide variety of foods and cuisines nowadays can broaden your palate and lead to the acquisition of new tastes. In addition, positive or memorable experiences with specific foods can lead to the acquisition of a taste for those foods. For example, if you associate a particular food with a happy or significant memory, you may develop a liking for that food.
As we've seen, the tongue is not only a vital part of our daily lives, but also an undercover hero. So, next time you enjoy a delicious meal or engage in a heartfelt conversation, remember the unsung hero that makes it all possible.